So we're going to start section 6.3, and that talks about solving trigonometric equations. And the first example we're going to look at is 2 sine of theta plus 3 equals 2. And we're going to focus on theta existing between 0 and 2 pi, so just one lap around the unit circle. And we need to solve for theta. So we know that theta is going to be one of our angle measures. So the first thing we'll do is we'll subtract 3, which this becomes 2 sine of theta equals negative 1. And then dividing by 2, we get sine of theta equals negative 1/2. Okay? Now, sine is negative in the third and fourth quadrant, and it corresponds to pi over 6. So we go 1, 5, 7 pi over 6, and 11 pi over 6. And there's our answer. Okay? So we solved our equation. Let's look at a couple more examples. If you have 4 cosine squared of theta equals 1, again, we're just going to concern ourselves with one lap around the unit circle. So the first thing we'll do is divide by 4. This becomes cosine squared of theta equals 1/4. Then to undo the squared, we'll square root. So we have cosine of theta equals plus or minus the square root of 1/4. Now, we know that the square root of 1 is 1, and the square root of 4 is 2. Okay? So we want to know where cosine is positive 1/2 and negative 1/2. That means we care about all 4 quadrants, because this is where cosine's positive and this is where cosine's negative, and we want both answers. So theta is going to correspond to pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. In this case, we have 4 answers. All right, now down here, if we want to solve for theta, we'll add 1 over, divide by 2. This becomes sine squared of theta equals 1/2. Again, we need to square root, so this becomes sine of theta equals plus or minus the square root of 1/2. Well, the square root of 1/2 is 1 over the square root of 2, but we don't like square roots in the bottom of our fraction, so we'll multiply both the top and the bottom by the square root of 2. So this becomes sine of theta equals plus or minus the square root of 2 over 2. We want to know where it's positive, where it's negative, so again, it'll happen in all 4 quadrants, and sine has a square root of 2 over 2 value at all of the pi over 4s. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And those are our answers. Okay, now this one gets a little bit more interesting. It says sine of 2 theta equals 1/2. You'll notice the 2 is inside the parentheses, and so what that actually affects is our domain. Right now, we're saying that theta exists between 0 and 2 pi, but we don't want just theta, we want 2 theta. So what we're going to do is we're going to multiply our domain by 2. So now our domain is 2 times 0, which is 0, less than 2 times theta, which is 2 theta, and 2 times 2 pi, which is 4 pi. What that tells us is that we actually get to do 2 laps around the unit circle instead of just 1. So we're asking, where is sine 1/2? We know that sine is a y value, and the y value is 1/2 at pi over 6. That's the first quadrant. It's also positive in the second quadrant, so we also need 5 pi over 6. Now, this is the first lap around the unit circle. We need to do another lap, and to do another lap, you simply add 2 pi. Since it's pi over 6, to add 2 pi, that's the same thing as adding the top by 12, because 12 pi over 6 is the same thing as 2 pi. So if you take 1 pi plus 12 pi, you get 13 pi over 6. And if you take 5 pi plus 12, you get 17 pi over 6. So these are the 2 answers on the first lap around the unit circle, and these 2 are the answers you get on the second lap around the unit circle. Now before, we just said that theta equaled these radians, But it's not just theta by itself anymore, it's 2 theta. At this point, theta is not by itself, so you have to divide each of these fractions by 2. And when you divide by 2, that changes the denominator. So theta is going to equal pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. You cannot reduce any of those fractions, so all 4 are answers. Okay, so down here, we've got this 3, and we can't really get rid of it yet, but what it will change is our domain. So we'll come over here and we'll multiply each piece of our domain by 3. 3 times 0 is 0, 3 times theta is 3 theta, and 3 times 2 pi is 6 pi. So for this time, we get to go 3 laps around the unit circle. Now, sine equals -1 at 3 pi over 2. And that's the only place on the unit circle that your y value is -1. So this is our first lap around the unit circle. To do our second lap, we're going to add 4 pi, because 4 pi over 2 is the same thing as 2 pi. So if we take 3 pi plus 4 pi, that gives us 7 pi over 2. And then we need a third lap, so we'll add 4 pi again, and that gets us to 11 pi over 2. So this is our first lap, second lap, and then third lap around. And instead of just writing theta equals these, we're going to write 3 theta equals those. And again, to get theta by itself, you're going to divide by 3. So theta is going to equal 3 pi over 6, 7 pi over 6, and 11 pi over 6. In this example, this one does simplify, so our final answer is going to be that theta equals pi over 2, 7 pi over 6, and 11 pi over 6. And those are our 3 answers. Now down here, on this last one for this page, our domain is going to be affected because we're going to divide everything by 2. Or if you like, multiply everything by 1/2. Okay. Now half of 0 is still going to be 0. Half of theta can be written as theta over 2. And half of 2 pi is pi. So for this example, we actually only get to do half a lap around the unit circle. And we just care about quadrants. That just gives us quadrant 1 and quadrant 2 to look for our answers. Now, tangent is equal to the square root of 3 at pi over 3. Since it's positive square root of 3, tangent is only positive in the first and third quadrant. Okay? But we just said we can only look at quadrants 1 and 2 for our answers here. So in fact, there's only going to be one answer, and it's just the pi over 3. Now, on this side of the equation, we have theta divided by 2. Clearly, theta is not by itself, so we're going to multiply both sides by 2. Since we're multiplying by 2, it's going to go to the top, so theta equals 2 pi over 3. And there's our answer. I have 2 more examples for you. Now let's say you have something like secant of theta equals square root of 2. We're really good on the unit circle with sine, cosine, and tangent. So there's no reason why you can't rewrite this. Okay? Just take the reciprocal for both sides. The reciprocal for secant is cosine of theta, and the reciprocal for the square root of 2 is 1 over the square root of 2, which we know changes to square root of 2 over 2. So now our equation that we need to solve is cosine of theta equals the square root of 2 over 2. Since theta is by itself, like there's not a 2 in front of it, there's not a 3 in front of it, there's not a 1/2, we don't need to change our domain at all, so we just care about going one lap around the unit circle. Cosine is positive in the first and fourth quadrants, and it happens at pi over 4, 1, 3, 5, 7 pi over 4. Okay, so those are our 2 answers, pi over 4 and 7 pi over 4. We'll do the same thing down here. Keeping in mind this time we do need to fix our domain, so we need to multiply by 3 and we need to divide by 2. So taking care of that, 3/2 times 0 is still going to be 0. 3/2 times theta is 3 theta over 2, which gives us what we have in here, so that's good. And then at the end, if you take 3 times 2, that would be 6 pi over 2, but we know that that reduces to just being 3 pi. So in this case, we're going to go 1.5 laps around the unit circle. Now, since this is cosecant, let's do the reciprocal. This will become sine of 3 theta over 2 equals, the reciprocal on this side, is -1/2. And if you're using reciprocals, you have to use it on both sides of the equation. You have to play fair. If you only do it on one side, it will not work. So sine is your y value, and it equals -1/2 at pi over, excuse me, pi over 6. Now, sine is negative in the third and fourth quadrants, okay? Now, if we're doing 1.5 laps, that's like going here and here. Well, it's still going to have only 2 answers because my 1.5 laps only touches the third and fourth quadrant in the first lap around. So that's 7 pi over 6 and 11 pi over 6. So we'll set this equal to 3 theta over 2. All right, so then to get theta by itself, we'll multiply by our reciprocal. So we're going to take 2/3 times 7 pi over 6 and 2/3 times 11 pi over 6. Just doing some simplifying there. That becomes 7 pi over 9 and 11 pi over 9. And those are your 2 answers. And your assignment for tonight is section 6.3 worksheet, no calculator.